Okay. Those of you who are new, by the way, I record one class, and so today is a lucky class. And I post the video on my website, so if you're absent, or even last period, a girl said, I watched your video while I did my homework, and it helps so much. Yay, that's a great idea. Watch the video while you do the homework, and it would help so much. Okay, so if you're absent, or if you want to study for a test, Ms. Grace back, wblue.com. The videos will be there. Just click secondary 2. All right, to start off today, everyone needs a triangle. Title put on the top, angles. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 2, 3. Four. 2, 3, 4. Okay, pick a triangle and pass it back. You're going to want to turn your lined piece of paper this way, horizontally. You need one more? Okay, if you're in a notebook, turn your notebook horizontally. Okay, pass that back. The first thing you're going to do is, pretend my paper is horizontally. Let's see, I need a triangle. Isn't there a shape? Here's a shape thing. Triangle. Come on, move. Okay, what we're going to do is, let's see, Law, can I borrow your paper? Your triangle as a demo. Okay, you can turn, we need to be going across the page, so turn it horizontally or you're going to run out of room. Okay, near the edge of the paper, can you put your pink triangle like this? Near the edge of the paper, so it is parallel to, the base of the triangle is parallel to the bottom of the page, otherwise you're going to run out of room. Okay, near the edge, go all the way near the edge. It's okay if it's over your title. And would you trace it, please? Okay, trace it, and then I'm going to give you some crayons. Okay, oh, perfect.
Or like that.
So we turn the paper horizontally, and put it to the edge and trace it. Okay? Then I'm going to give you a box of baggie of crayons. Pick 3 colors, and color each of the angles a different color. Okay, go all the way up to the edge of the paper. You're going to run out of room. So then take a baggie of crayons and color, oops, there's a ruler in here. Color each of the angles a different color. Color each of the angles a different color. So I'm going to color mine like red, green, and blue. Did you color the angles different colors?
Yep. I think I
Okay, last class we talked about a word for the triangles? Go ahead. Thanks for waiting. Okay. Last class, we talked about a word that represents the tip of this angle. The tip of these angles. Does anyone remember the name for that? Lucas? Vertices. Okay, this right here is a vertice. Vertice. Okay, so there are 3 vertices on your pink triangle that we cut out for you. We need to find the midpoint of every side of the triangle. So raise a hand, who can tell me what a midpoint is? Middle of the center. Oh, so like right here? So center of the triangle, you mean this is the midpoint? A line goes on forever. I don't see any lines here. I don't see any lines. Lines have arrows on both ends that go along forever. There's a line segment. Oh, line segment. Okay. So you're looking for the middle of each of the line segments representing the sides of the triangle. There are 3 sides. So you need to find 3 midpoints. How would you find a midpoint on your pink triangle? You could measure, that's true. But I didn't give you rulers. So, how could we find it without a ruler? Fold! So, take your pink triangle, go vertice to vertice, fold it completely over. Yesterday people were folding weirdly, I don't know how that... So, the vertices are the points, right, where the angle is. Fold one vertice all the way over to the other vertice. And if you crease it, it will create the midpoint. We do it... Jamie, do you have a target note? Okay, we do it again. On all 3 sides, you should find 3 midpoints. 1 midpoint per side. 1 midpoint per side. And for mine, since I don't actually have real paper, I'm just going to eyeball it. Find the midpoint. Fold one vertice all the way over to the other vertice. Fold one vertice all the way over to the other vertice. Once you have your 3 midpoints on your pink paper, your pink triangle, then relay the triangle on the one you traced and mark the vertices on your paper. Not the vertices, I'm sorry, the midpoints. Mark the midpoints on your paper. Mark the midpoints on your lined paper. Do you need help? Yep, so just connect the corners and crease it. So that's 1, then you have to do it again. So here to here, and you find the midpoint by connecting the corners and creasing it. You need to do it 3 times. And then mark them on your lined paper. Jamie, will you put your bag down on the ground, please? Good. Now mark it on the lined paper. Okay. So just put a mark right there where the crease was. Mark it on your notes. Mark it on your notes. Yeah, you just need 1 more. Which one are you missing? This one, here to here. Okay, now mark it on your paper. Okay, you can't... Did you fold your line? Okay, this is supposed to be the exact same triangle I gave you, Jamie. And you've only folded once. You need to fold 2 more times. You need to find the midpoint. You have the midpoint here. You need to find the midpoint here and here. Okay, you found them? 1, 2, 3, yeah. Now lay it back on the top of the triangle and mark it on the paper. No, not really. You just have to see this is the midpoint there, there, and there. What? That was just a crease that went through. Okay, so the midpoint is here, here, and here. Okay, mark them on your paper. We need those midpoints. Ooh, I'm going to see if I can select all of this and combine it. How do we do that? Lock. Nope, that is not what I wanted. Lock. Group, thank you. That's what I wanted, thank you. Lock means I can't move anymore, and I still need to move it. Jonathan? Thank you. Everyone should have their midpoints marked on your notes, your lined paper. Okay. Who can describe for me what it means, or demonstrate? Let's demonstrate. Who can demonstrate for me a 180-degree rotation? Who can demonstrate for me 180-degree rotation? You can, Andy? Okay. Stand up. Stand up. Demonstrate, please, a 180-degree rotation. Okay, can you do it with your body? 180-degree rotation. I don't know what you're doing.
Yeah, do a backflip and land on your head.
Okay. We've heard of like 180-degree flips that you guys are talking about in like snowboarding and the skateboarding, right? Okay, so would you agree that 180-degree rotation, Andy, see if I'm doing it right, is... Yeah? No. I'm hearing no's. Why are you saying no? Oh, so I have to go all the way around. Oh, that's 360 if I go all the way around. So, this is 180, correct? This would make it 360 if I combine the two. Okay, so, let's see, I need to copy this and paste it really quick. What we need to do is rotate our triangle about, we're going to rotate the triangle about the midpoint. Now this little rotation tool for me rotates it about the center of the triangle. So about the midpoint means that's your pivot point. Can I borrow yours again, Ma? So what you need to do, replace your pink triangle on the paper. So, put the mic over there. Okay, and then you need to put your finger on the midpoint that's closest to the center in your paper, so we have room to move. And that's your rotation pivot point. And you're going to rotate the triangle 180 degrees. It just goes. Okay, sorry. I'm going to try it on a hard surface and still in all your supplies law. Okay, there we go. This is much better. Okay, so that's my pivot point. I found the midpoint, put my finger on it, and we rotate the triangle 180 degrees. Notice, does it rotate onto itself? No, it goes next door, doesn't it? Does it go next door? So you need to rotate your triangle 180 degrees about the midpoint, which this would mean you'll see this happen. Isn't that what you get? How about the midpoint? You're doing on the vertex, the vertice. About the midpoint, because we're moving into geometry. The next few months is geometry. That's why we're learning about triangles. Good. Once you've done the rotation, trace it. Once you've done the rotation, trace it. 180 degrees. So 180 degrees means it goes like that. And then trace it.
From right there is the midpoint?
Okay, 180 degrees means you put your finger here on the midpoint, and you go like that. Jonathan, where's your paper? Let's trace it. Put the triangle back on. Put your finger on the midpoint, which should be here. You marked it up there, I don't know why. Okay, and rotate 180 degrees. The pink part. 100. Oh, you have to hold your finger steady. Wait, let go for a sec. Is it easier? Okay. Put your pencil. I don't think this is. That's better. Put your pencil right there. And then rotate 180 degrees like that. And then trace it. Once you get it, trace it. They should be touching. You have a little bit of space. They should be touching.
Oh, sorry. So it's supposed to end up like
that?
like that?
Yep. Yep. After you have traced it, you need to color code it, but your color coding has to match up. So think of how you rotated it. Oh, my color coding, I cheated a little bit because I locked the colors on the triangle. Okay, if I rotate it, at the beginning, the blue angle was on top. And then when I rotate it 180 degrees, my blue angle is on the bottom. Do you see that? And at the beginning, my red angle is on the left, but then when I rotate it 180 degrees, it's now top right. So color code your corresponding angles the same way you were color coding the first triangle. The angles should correspond to each other. That works. Good job. Color in the angles of the second triangle that you've traced. Sorry, Justice, you had a question. You can just redo it. Just start right here. Draw another one. And then rotate it, and then you'll be going the right way. Okay? Start right there. Okay. So we're going to be doing a lot of inductive and deductive reasoning. Does anyone know the difference of inductive and deductive reasoning? Shh, listen up, please. Inductive versus deductive reasoning. Have you heard those words before? Oh, I say it a lot in Acuity. When you're taking the test and you guys are complaining about having to show work, I say, well, use deductive reasoning or inductive reasoning. Inductive reasoning is the process of examining many examples, noticing a pattern, and stating a conjecture. So you're observing examples, and you notice something happens every time, and you state a conjecture. Conjecture is kind of like a hypothesis. Deductive reasoning is the process of starting with statements assumed or accepted as true. Okay? So, what do we notice after we've rotated a triangle about the midpoint and we've retraced it? What have we developed? What do we have? You all have this on your paper. I've seen yours. What? What did we create? Oh, say that? Okay, Jaren thinks we've created a parallelogram. Parallelogram. Okay, let's talk about the attributes of a parallelogram. Shh. Who knows one thing about a parallelogram, an attribute about a parallelogram? Yeah? 4 sides. Do we now have 4 sides on the outer edges? Yes, okay. What do you mean by even? What do you mean by even? Are you talking about the same? Oh, there's the word I want. Length. Okay. Are all 4 exactly the same length on a parallelogram? Sometimes. Okay, if it's a square, is a square a parallelogram? Okay. Now, for the same length, meaning they're congruent, right? On a parallelogram, if all 4 don't have to be congruent, how many do have to be congruent? 2. So only like the top and bottom have to be congruent for it to be a parallelogram. Two times 2. You're saying 2 pairs? 2 pairs of sides have to be congruent. Oh. Okay. We have to have, like, the bottom and the top would be a pair. Those would have to be congruent. Is that what you're saying? And then the left and the right sides would have to be congruent. Is that what you're saying? That's another pair? Okay, good. I know you're going to be annoyed with me. I'm going to be asking, I want specifics out of you today. Okay, so we see, it looks like, that's what we have. It looks like the green, top and bottom, are congruent. It looks like the left and right are also congruent. What else do we know about a parallelogram besides we have at least 2 pairs of congruent sides? We know that there are 4 sides. What else do we know about parallelograms? What are parallel? The congruent sides have to be parallel. Okay, so up here, the top and the bottom would have to be parallel. Same with the left, oh, that's not green. Let's try that again. The left side and the right side would have to be parallel in order for it to be a parallelogram. Right? That's what a parallelogram is. How do we know that when we took the triangle and we rotated it about the midpoint, and we're saying both triangles combined create a parallelogram, how do we know that those lines are actually parallel? Okay? They look the same, yes they do, but how can we prove that they're actually parallel? Mara? Okay, we have the same exact angles. So, for instance, this angle, we're just having a discussion, okay? This angle and this angle are the same, which means those are opening widthwise at the same angle. And these are opening widthwise at the same angle, okay? Interesting. What else could help us prove that we actually have parallel lines? Because it looks parallel, but we have nothing on there right now that proves they're parallel. We can't just assume they're parallel. We have to know for a fact that they are parallel. Okay, how would midpoints help us prove that they were parallel? Midpoints match. What else do we have on a triangle besides angles, sides, and midpoints? Did you say hips? Oh, the vertices? Okay. I believe we have something inside the triangle. That is the information we need. What do we have inside the triangle? What? Okay, let's talk about area of a triangle. What's the formula for area of a triangle? It's actually 1/2. Base times what? Where is the height of this triangle? It's on the inside, is it not? This is called the altitude. So, say this altitude, or the height of the triangle, is height h. What does it tell you about the other triangle? Same what? Same altitude. Alright, so, question. If we gave this a title, if segment, where is it? BC, if segment BC is the same distance, what are you guys laughing about? You want to share something with us?
love this. Just love it. We're excited about it.
Okay, point B is h distance away from AD, correct?
Yes.
H distance. Well, point D is also h distance away from BC. So if we have supporting bars, or the altitudes, that are exactly the same height, then if, like, say we're building a building, and the supporting beams were exactly the same height, would our building be lopsided?
Yes.
No. Our floor and our ceiling would then be not lopsided, but straight, or what's the P word? Parallel. So we just proved that this is in fact a parallelogram because the altitudes were equal. So it is a parallelogram. Okay. Well, if you would overlay your pink triangle again on your newest triangle that you've created, the one more center in your paper, put your finger as the pivot point. No. Put your finger as the pivot point, and we are going to do another 180-degree rotation. Put it on the second triangle you made. Another 180-degree rotation. So I'm just going to cheat a little bit. I'm going to take that word away. So you should come up with something like this. If I took my upside down triangle and I rotated 180 degrees to about the midpoint. Then if you could, color code, so you need to rotate. Put your finger there, and you rotate 180 degrees. Well, I think your triangle is not. I didn't line it up right. Because it should come out. There we go. I think I moved my finger, but it's supposed to be like that. Okay. Trace your triangle and then color code the angles. Color code the angles of where they rotated to their corresponding angle. Good. Yep. Trace that, then color code the angles. Color code the angles. You want to go about the midpoint. So your outside midpoint right here. Okay, and then rotate that way. There you go. Hey, I need you to color code the angles, please. That looks nice. Good. Olivia, can you color code your angles, please? Color code your angles. It's important that we have the angles color coded.
Because.
Yes, I do like colors, but there's a reason behind my madness. All right. After we have color coded your angles, I'm going to, let's see. I think I'm going to delete my highlights because I have a lot going on. It's getting a little busy. Oh no, what's this? Yeah, I want to delete that. Delete that. Delete that. Okay. So when we did one rotation, we found out and proved that it created a parallelogram. We proved it was a parallelogram because we understand what an altitude is, the height of the triangle, and by rotating 180 degrees, the altitudes of both triangles were equal. Now we've rotated another 180 degrees, and what have we formed? Oh, a trapezoid. I hear the rhombus word. Oh, it looks like trampoline, huh? I never heard that one before. Okay. Can I help you? What do you need her for? We have two Dianas, I think, in here. Which Diana? Okay. Sure. Okay, trapezoid. There is a hand. Can you tell me an attribute we know about trapezoid, Michael? Oh, apparently. 3 triangles together. Okay? Yeah. The top and bottom of a trapezoid would be parallel. Do you agree? Or if you flipped it, at least 2 opposite sides of a trapezoid have to be parallel. Right? Depending on its orientation. Okay? So we know that 2 opposite sides are parallel. What else do you know about a trapezoid? There are 4 sides. Does anyone know the name of a 4-sided 2-dimensional object? They're not all squares. That is one, but the general name. Octagon has 8 sides. But you have the right idea. We're going, oct means 8, so quad means 4, right? It's a quadrilateral. Quadrilateral. Did I spell that right? Okay, quadrilateral. Now, do the other 2 sides, like say this side and this side, do they have to be parallel?
Yes.
For a trapezoid. Okay. They have to be opposite. What do you mean by opposite? They look the same, but their slopes maybe are opposite? Ah. Okay. They'll eventually cross each other. I like that. I have a question about this shape. Is this a trapezoid?
No. Yes.
Trapezoid?
Yes.
Parallel sides? This is a trapezoid. So the only requirements are 2 opposite sides are parallel. The other 2, however, are not parallel. It could create a 90 degree like this, or they could both be slanted with like opposite slopes, like the one we have above. So how do we actually know? And you guys should be able to answer this now if you've been listening. How do we actually know that? Let me get a different color. That this side, the top, and this side, the base, are actually parallel. How can we prove that those are actually parallel? No. She's not here. He is, though. He's in the counseling center. Guys, where I put the teal highlight, how do we know the base and the top are actually parallel? If you've been listening, I've already told you how to prove this. If you've been listening, I already told you how to prove this. Nemo, can you explain how we can prove for Shorty that the base and the top are parallel? Shh. Height of what? Okay, so you're saying height of the trapezoid's right here, and we call that the altitude, right? The height. How does just one height prove that it's parallel? Can we prove they're parallel by just one height? How many heights do we need for altitudes? At least 2. These are kind of like, if we're building a building, these are like the support. Oh look, I already have H written there. Okay, we need 2, and if the braces are the same length, then our building won't be lopsided. It would be perfectly straight because our floor and our ceiling are now parallel. Okay, so because these triangles are in fact congruent, do you agree the triangles are congruent? We use the same triangle, we just turned it and turned it. So since we know that the triangles are all congruent, then the heights or the altitudes are exactly the same, so therefore it is parallel. So this is a trapezoid. Okay, all of that stuff about parallelograms and trapezoids are trying to also prove, I'm going to erase this. Oh, that took off more than I wanted. Okay. I just want to take the highlights off. What did we prove last time? We took a triangle and we ripped it apart? Remember last time we took a triangle? Michael. This way, please. We took a triangle and we ripped it apart, and what did we do with the triangle last time? We rotated them around so all the points were together and formed. What happened when we put all the points together? The vertices met at a single point. Oh, it made a straight line, and this straight line, what do we know about that? It is 180 degrees, which means it's actually an angle, and this angle has a name. A straight angle, which makes sense. Okay. We proved that this was proving that you can take any triangle and all three angles sum to 180 degrees. No matter what type of triangle you get, big, small, obtuse, right, triangle, all three angles sum to 180 degrees. Oh, I think I've lost a triangle. You can still see here and here. For some reason, my triangle's gone. I must have deleted the wrong thing. Oh, let me undo this. We need that triangle back in order to answer this question. There we go. Okay, you can look at yours. Yours is less messy than mine is because I've been drawing all over mine. What can we prove about angles of triangles based off of what you've rotated, drawn, and colored? What can we prove about triangles? Okay, we know that now multiple shapes such as parallelograms. How many triangles did it take to create the parallelogram? 2 congruent triangles. How many congruent triangles did it take to make the trapezoid? 3. What would happen if we rotate one more time? What shape would we get? If we rotate one more time and have 4 congruent triangles up there, what shape would we get? A big parallelogram. Oh, so maybe when we have 2 triangles and 4 triangles, we get parallelograms. What would happen if we had 6 triangles? 6 triangles. No? Oh, he has it over there. Parallelogram. So 2 triangles. 2 triangles when we rotate it creates a parallelogram. 4 triangles when we rotate same way rotation 180 degrees creates a parallelogram. 6 creates a parallelogram. So I'm going to make a guess that 8 would create another parallelogram, just bigger. And 10 would probably create a parallelogram. What are all these numbers? What do they have in common? Starts with an E. They're all even. So even number of congruent triangles creates a parallelogram. So 3 created a trapezoid. I'm going to take a guess that 5 creates another trapezoid. And 7 creates another trapezoid. What do these numbers have in common? Odd. So odd numbers would create a trapezoid. Okay? But my main question is we are proving, what do you notice right here? Right here. Shh. Guys? Hey, Jackson? Shh. What do you notice right here? Oh, I heard it. 180 degrees, it makes a straight angle, and look at the colors. We have all corners, all different colors, and in our triangle, how many crayons did you use in total today? 3. So right here, when we've rotated twice, we've actually ended up with all 3 angles of the same triangle. Guys, I can't take that anymore. Please stop. All 3 angles of the same triangle were able to, when rotated twice, created a straight angle. And they all meet together like a puzzle. And what does this prove? What does this prove about three angles of a triangle? They all add up to 180 degrees. So we proved it two ways, actually. We proved it last time by taking one triangle and ripping it. We proved it a second time today by taking the one triangle and rotating it twice. Okay, time to actually start writing some notes. Well, it's not even very long, guys. Don't moan and groan. Okay, triangle angle sum we've now proved twice. The triangle angle sum theorem. No, this is on the same paper. Same paper. If you don't have room, flip it over to the back. This is all the same notes. We don't need the pink triangle anymore, but this is all part of your notes. Triangle angle sum theorem we've now proved twice in two different ways. And you've all had different types of triangles, so it's probably going to be applicable to all triangles in existence. We know now, and we've proved it twice, that the sum of a triangle's, apostrophe S, well that's a huge eraser, triangles angles will always equal, what? 180 degrees. Or you can say that the three angles in a triangle sum to 180 degrees. Okay, we proved that twice. I hope that's something that you firmly believe now and can accept firmly. There are a few other things we need to go over today about angles. And you've probably heard these last year in math, so we're just reviewing a little bit. We have the triangle angle sum theorem about triangles. With angles, we have complementary. Oh gosh, I'm having issues spelling today. Complementary angles. Leave a space for that definition. And we have supplementary angles. Complementary and supplementary angles. There is a hand. Who thinks those sound familiar? You've been exposed to those vocabulary words before? What? Well, 5 seconds ago, yeah. But before 5 seconds ago, did you hear about these? Maybe last year? You heard about them previously? Yes and yes. Okay, complementary and supplementary. Some of you raise your hands that you've heard about these before. Does anyone remember the definition of complementary angles? Complementary angles. Yeah? Exact same angle would just be congruent. All right, I'll refresh your memory. Complementary angles are two angles whose measures have the sum of is it sparking in memory? 90 degrees. Oh. So an example of those, that would be angle A and angle B. If A was, say, 70 degrees, what would angle B be? 20. It has to add to 90. Okay? And together they create the 90-degree angle. They're complementary. Supplementary is similar definition. Two angles whose measures have the sum of, but it changes. 180. Okay, so this is two angles whose measures have the sum of, let's underline those, 180 degrees. Supplementary, create 180 degrees. So examples of that would be A and B. If A was, say, 152 degrees, if A was 152 degrees and it has to sum add up to 180 degrees, Janine, can you tell me the measure of angle B? 28. What do you guys think? Do you agree 28 would make it 180? Yeah, 28 degrees. And when these two angles, these two supplementary angles, are actually sharing a side, when different color. When these two angles are actually sharing a side like that, those are called adjacent angles. Oops, I don't want that button. Adjacent angles. Okay, for instance, I live in a townhome. What do we know about townhomes compared to single family homes, what they call them? Or apartments even. What do townhomes and apartments have in common that a single family home doesn't? You live next to people, and do you share anything? Yes, you do. You share, like a townhome, or a condo, or an apartment, you probably share a wall. Yeah. So adjacent angles, think of them as neighbors living in a townhome. They're neighbors, and they share a wall. Okay, so let me get the official definition instead of my townhome definition. Adjacent, yeah. Two angles with a common vertex and side, but no common interior points. Two angles with a common vertex and side, but no common interior points. So they don't overlap. They don't overlap. They come together and meet at the wall, and they don't overlap. So the example above are two angles that are adjacent. So when these two angles be adjacent? Why not? They don't share what? A wall. And technically they need to share a vertex, which is right there, vertice. Is this for me or for her? I think it's for her. Diana A. Okay, so these two are not adjacent. They are not sharing a wall. But these two would be adjacent. So it doesn't even have to create a straight. We could even make it go like this. Angle A and angle B. So it doesn't even have to create a supplementary angle. So A and B are adjacent angles. A couple other vocabulary words. Supplementary angles also create what's called a linear pair. Linear pair, and we also call it a straight angle. Oh, thank you. Straight angle, and I'm going to put supplementary again. Supplementary angles. Okay, 3 different vocabulary phrases that all represent something that looks like this, A and B. Linear pair, straight angle, supplementary angle. Is that good? And the very last one are what are called vertical angles. Vertical angles. And who likes to play basketball? Basketball? Okay, volleyball? Oh, more volleyball. Okay, what's your vertical, I think they call it vertical leap. But in basketball they say, LeBron James has a vertical of this. What does that mean? How high he can jump. Okay, so we're talking like vertical means up and down. Okay, so vertical angles are when two angles intersect. With crossing lines, angles A and B would be vertical. Now they don't actually have to be up and down. We could, though, show them here, A and B. Okay, two intersecting lines create vertical angles. And we also know that these vertical angles are congruent. So two intersecting lines create two congruent is the thing you really need to take away from this. Congruent vertical angles. So here A and B are also congruent because they're vertical angles. For the rest of the class, we're going to be getting into partners to work on our homework. Our homework is not online, but don't forget that your online assignment from last time is due by 11:59 tonight. We have this green packet. Okay, you're going to get together with a partner and work on them. Now, guys, the whole first page, we have answered all of these questions together already. So with your partner, discuss the question and figure out how to write the answer in a complete sentence. And be careful, some of the questions actually are asking you to answer three things. So if you put one word, that is not answering all three things, nor is it a complete sentence. I would appreciate complete sentences. Okay, so you may move if you like and bring your crayons on your move. Make sure the bag is zipped up. Throw them here in the basket. Find a partner you would like to work on your homework with for the rest of class. Find a partner you would like to work on your homework with.